Welcome to blockchain technology. Last video we saw about a proper definition of what is blockchain and how a blockchain is and what is it used for. And today we are going to see a brief explanation on how a blockchain works. That is, what is the underlying technology or a technique which makes the blockchain to work. So in this slide, I have given a proper architecture of how a blockchain works. Blockchain is normally done for some transaction of data. It can be some transaction of money, or it can be transaction of some messages, or whatever it is. So in normal databases, the data transactions are stored directly into the databases, or it uses some kind of encryption. But in blockchain, before getting stored into a database, it sends that particular transaction to a particular set of nodes in the network. That is, if that node which is performing the transaction has a network which connects to 100 users or 100 of its peers, it sends that transaction to all the nodes, that is to all the 100 peers. So that 100 peers will verify whether that transaction is a genuine one or it is an authentic one, and based on some kind of voting mechanisms or what we call as consensus mechanism, it will validate whether that transaction should be included into the blockchain or not, and then it is included into the blockchain. So if these nodes are not allowing, means that is, it is not getting a validation from a particular set of nodes, or a maximum number of nodes are rejecting that transaction. So if the transaction is successful, then it will create a new block and it will add it to the blockchain. This system is more transparent and it is less tamperable, and it cannot be hacked as easily as the traditional databases, and then the transaction gets complete. This is the principle of how a blockchain works. Now I'm going to use my whiteboard to explain how a blockchain works. So let's switch on to the whiteboard now. So we are going to see about how a blockchain works. So imagine we have a computer which is performing one transaction, and that computer system is connected to some other nodes in the network. It can be in a LAN, or it can be in the internet, or it can be even to a metropolitan area network, or whatever kind of network, or any topology, whatever it is. So how this transaction gets committed into the database? What it does is, firstly it will send this transaction to all the nodes in the network, and then these nodes will examine whether this transaction is valid or not, and based on some information given by these nodes as feedback, it will be identified whether this transaction is genuine or not. Then once the transaction is marked as genuine by most of the nodes, the transaction is marked as valid, and then it will be stored in the database. Likewise, we have another transaction getting connected. How it get connected? It will follow the linked list based connectivity. That is, it will have a hash value for this particular node. For example, I mentioned it as hash 1, and then this hash 1 is stored in the second transactions block. So this will have another hash, let's say it is hash 2. So this will have like hash 1 already along with the data. So this will also have a data, and then the third data you have another hash, let's say it is hash 3. So in this block hash 3, it stores the hash value of the transaction number 2. So then it will have all the data and then it keeps on going. So this storage of hash values of various transactions, it will form it as a block. This is what we call it as block. A block can have a set of transactions. How many transactions does a block can have? It depends on the blockchain. We can define how many transactions a block in a blockchain can hold. So if the block which is storing the transaction is full, I mean the storage space is done, then it will create a hash for this block, and this hash will be carried on to the next block as the previous hash header, and then it keeps going on connecting to the blocks. So if a hacker wants to tamper a data, he needs to find out the hash value of the previous node and the hash value of the next node, and then he has to alter it. But before altering, he has to find out what is the actual value stored behind that hash value, which is relatively impossible to hack within a short period of time. And even if he does any tampering, that transaction cannot be committed unless all the nodes in the network will validate. That is practically impossible, so the blockchain will remain safe with this kind of storage. So for verification, it does something called as consensus algorithm. So we will discuss about this in the next few weeks, what consensus algorithm is and what are the types of consensus algorithms available. We will see in the weeks to go. So then this will have a data structure of how a block is done, and that will be explained. Now we are going to see how it is different from the traditional storage of data. So in the left side, we have a normal banking based transaction where the people use the cards to send money from one person to another. So it will be like if the transaction is agreed between the two parties, and if there is no matter how many people are in the middle, it will get committed and it will stored in the database. But in the blockchain, there are n number of nodes connected with all the other nodes, and these nodes will transmit the transactions to all the other nodes, and upon getting a verification from all the nodes, for example, the system in the top will have a transaction and it will send it to all the nodes across the network. So all these nodes has to give a validation. If the validation is not obtained, that transaction is not validated. So when we think about what blockchain is, it is distributed encrypted database in the first hand. And then when we make about with the transaction, it can be also called as a distributed ledger technology. And then it drives to you and next generation internet, and then it is for a tool for a decentralized world. That is, you don't need to rely on one server for the storage of information. If one node in the network fails or the server fails in blockchain, it can retrieve the same data from any node which is present in the network. So this is one of the advantages of having a blockchain. And now we are going to see a brief history of blockchain. The concept of blockchain was started in the 1990s when Satoshi Nakamoto introduced blockchain in a white paper in 2009, but the distributed computing was started in the 1990s. This is the base for blockchain. So Nakamoto's white paper is in the year 2009, and then they started to do this Bitcoin transactions from the year 2011, 12 to 13, and then the Bitcoin started to have a boom in the financial market during the years 2013 to 2014, and now it is using smart contracts, and then it is using various applications, and furthermore it is going with many advancements. So it is still growing on, and it is having some generations: blockchain 1.0, 2.0, 3.0, and 4.0. 1.0 is where Satoshi Nakamoto's white paper came out, and it gave rise to Bitcoin. And smart contracts, you can see, like it's like 2013 onwards we started using the smart contracts, and 3.0 is the distributed applications, which is from the year 2015. So blockchain 4.0 is the current generation of blockchain. We are all in 4.0, and still it is going on advancing with many kinds of combination of cryptocurrencies and various other consensus mechanisms, and also combining these with the smart contracts. So this is about the cryptocurrencies. Implementation of blockchain distributed ledger technology, or we call it as DLT. It is the advent of cryptocurrencies. The coins like Bitcoin and many others like altcoins or whatever it is, you can name it. So they all started to come during this blockchain 1.0. Bitcoin became quite more familiar, and now it is become like internet of money or cash for internet. And then the second generation, we have smart contracts. The smart contracts are some small computer programs that lives like a executable code when a transaction happens. This smart contract will get executed only when all the conditions in a contract gets validated. It's as simple as you are becoming a tenant to your landlord or your office space. So like you are going to have a contract between your landlord to stay in a particular place, and you will be given with a set of conditions, and the landlord also will be given with a set of conditions. Either of you violate the conditions, then the contract remains in a stake. Likewise, here for any transactions to happen, you have a set of conditions to follow, and it has to be validated, verified, executed, and it is arbitrated so that it is preventing the fraud. Stellar and Ethereum are prominent platforms for smart contract, and mostly nowadays people are using these two platforms for making their own smart contracts. And then the third generation is DApps, that is decentralized applications, that is decentralized peer-to-peer network. It will have a front end of mobile apps, so that is a mobile app will become a node for this blockchain. So this is also a blockchain of mobile nodes. That is, you have a mobile device and you install that mobile application, and it will act as a node, and then the transaction happening in that particular software will be validated by those who are having that particular web application. So right now it is running mostly in Ethereum platform. And then blockchain 4.0, it is like making blockchain 3.0 usable in real life business scenarios, that is making all these advancements of blockchain 1 to 3 to be in a practical form. They are making it as a real life scenario, and then it is making this technology to be usable for business demands, and it is for a long term automation. And these can be done for many domains. There is no limitation. You can implement in supply chain, and it can be used in financial transactions, IoT, health management, asset management, and many others. You cannot limit, like blockchain can be used only in this particular technology or in this particular discipline. It can be used anywhere. So these are the use cases of blockchain in real world situation. And for additional reading, we have this Satoshi Nakamoto's white paper, and you can use this white paper to know more about how blockchain was proposed and how it is implemented. And when you study with the advanced blockchains, you will understand what way it is varying and how far blockchain is advanced. So that's all about the concepts for the week 1. We have seen an introduction to blockchain. Also, we have seen the history of blockchain. So next week we have types of blockchain and generic elements and terminologies in blockchain. Until then, bye for now.